Okay, so we are factoring mostly trinomials. I think there's like one or two that are not trinomials, which is fine. But we're using the Snowflake method. So depending on whose class you were in, I think about 90 to 95% of the teachers last year taught the Snowflake method. So most of y'all know what I mean when I say that. There are a couple people I think learned the Burke method. If you were in Miss Burke's class, was anybody in Miss Burke's class? Okay, if you can show your work for the Burke method, then I don't care what method you do. If you don't remember it, then you need to pay attention and do this method. Yes? Cool. Okay, so always make sure they're in order. Always take out a GCF. I think all of them today are in order, but definitely always check for a GCF. So quadratic standard form is ax squared plus bx plus c. A always has an x squared or a letter squared. B always has a variable that's by itself, and then C has nothing. It's your constant. And this is how you set up the snowflake. So you draw your x with a line through it, A times C on top, B on bottom, AX, AX. So it'll make more sense when I show you what I'm saying. So look at number 1. So it's in order. There's no GCF. So let's find our A, B, and C. Well, what's A? What's B? And C? So A times C is -3. B is -2, which goes on the bottom. A is 1, so it's 1 with your variable x, 1x. Okay? And these will always match, and they'll always be your A with your variable. Okay, so now we're looking for what multiplies to give me -3 and adds to give me -2. Well, the only thing that multiplies to give me 3 is 1 times 3. So to get a -3, I know it's either this or this. Which one of those adds to -2?
Well,
The bottom. So it's going to be +1 and -3. You can always check that in your calculator. But here's our factors. 1 over 1 does not simplify. 1 over 3 does not simplify as like a fraction. Think of it as like a fraction. And so that's my answer. So we have x plus 1 and we have x minus 3. So you write the sides as your factors after you simplify them. Okay, so let's look at number 2. What's your A? B? C. Okay. So A times C goes on top. 1 times -6 is -6. B on bottom, which is -5. So then remember, your A is 1, so 1 in our variable is x. 1x, 1x. So now, what multiplies to give me -6 that adds to give me -5? So you can list out your factors. 1 times 6 or 2 times 3. I don't know what I was about to write. But it's -6, so one of these has to be negative. So which one would add to -5? Oops, sorry, it might help if you could see. Yeah, the 1 and the -6. So +1, -6. So there are our factors because 1 over 1 and 1 over 6 do not simplify. So x plus 1 and x minus 6. Now, if you put 1x plus 1 and 1x plus 6, is that okay? Yeah. Any questions with those when A is 1? Okay, so let's look at 3 and 4 when A is not 1. So, does it have a GCF before we get started? Well, what's your smallest number? Does 3 go into 7? No, and 3 is prime, so nothing else goes into it, so there's no GCF. So what's A? What's B? And what's C? Okay, so A times C, what goes on top? Yeah. 4 times 3 is 12, so 12 goes on top. And what's B?
7.
Mm-hmm. And then A is 4, so 4x, 4x. So what multiplies to give me 12 and adds to give me 7?
6 times 2, 3.
What is it?
3.
3 and? No. 4. 3 times 4 is 12. 3 plus 4 is 7. Remember, it has to multiply to give me 12 and add to give me 7. So does 4 over 3 simplify?
No.
So this is where things change when A is not 1. You have to see if they simplify as a fraction. 4 over 3 does not. So that's good. Does 4 over 4? Yeah, what does that give you? 1. However, we have to keep it a fraction. So what would I do to keep that a fraction? 1 over 1. Bring my x to the top and bring whatever symbol I have to the bottom. So it becomes x plus 1. So 4x plus 3, x plus 1. So I want y'all to try this one while I take attendance. So this is what your snowflake should look like so far, even if you haven't figured out your numbers. Now, have you figured out your numbers?
No.
Okay, so I'm going to remind you of the calculator trick. Do y'all remember the calculator trick? So if you struggle with finding these two numbers, you can use your calculator. And in Y1, you're going to type your top number, divide x. And in Y2, you're going to type your top number, divide x plus x. So they almost look exactly the same, except the second one has that plus x with it. So come to y equals, and you're going to type, so our top number here is what? 24 divide x, thank you. 24 divide x plus x. So see how they look almost exactly alike, except the second one has the plus x. Yes? So then I go to my table, and I have x, y1, y2. I'm looking for my bottom number in y2. Sorry. And whatever's here is what goes here. So we're going to go to our table, and we're looking for the bottom number, which is negative 11. Well, all these are positive, so let's go up. And look, there's negative 11. So what are my two numbers? Negative 8 and negative 3. Does that make sense? So your calculator can help you find those. Now on some of the smaller ones, typing the whole thing in your calculator is a waste of life. Just try to figure it out. Now, if you struggle with numbers though, use the calculator. There's no reason to struggle if you have a way to look it up, right? If it's a prime number though, like 3, the only options are 1 and 3. So don't do all that for prime numbers. So we know that we have 4x over 3 and 4 over 8. Do either of those simplify? Do y'all remember how to type fractions in your calculator?
Alpha y equals.
Yep, alpha y equals enter. So 4 over 8, you could always do it like this. I don't type negatives though because that throws y'all off. So it ends up being 1/2. So we get 1 over 2. Remember, bring over your x and bring over your symbol because the symbol stays on the bottom. So my answer becomes x minus 2. Now does 4 over 3 simplify? And if we're not sure, we can type it, and it does not. So 4x minus 3. Any questions with that? So I'll put this back up here so y'all can look at it anytime y'all need it during the practice. So flip to the back of the notes. Okay, look at, excuse me, this one. Does it have a GCF? No, A is 1. They don't all have an X, so we're good. So we have A, B, C. What's A? What's B? And what's C? Do y'all notice that the first term's a perfect square and the last term's a perfect square? Yeah. X squared and 36, those are both perfect squares. When your first term and your last term are a perfect square, this doesn't always work, but it does a lot of the time. So A times C is 36, B is 12, AX, AX. What times what gives you 36 that's the same? Is 6 plus 6 12? Okay, so when that first and last term are perfect squares, ignore the middle one. The middle one's not a perfect square, and that's okay. 9 times out of 10, that means it's a perfect square trinomial. Not all the time. Sometimes there's the odd ones that work that aren't perfect square trinomials, but this one did. So there's your answer, 1 over 6, 1 over 6. That does not simplify, so we get x plus 6, which is the same thing as saying x plus 6 squared. So if you have that perfect square on top, always check to see if it's 49, be like, well, the 7 and 7 add up to whatever's at the bottom. So this is called the perfect square trinomial. Now, if you don't notice it's a perfect square trinomial, does it still work the same as all the other ones? Yeah, so it's not a big deal if you don't notice. It might just help you find your numbers a little faster. Okay, now look at number 8. What's different about number 8? Not no C, no B. So technically, if you found your A, B, and C here, A is 4, B is 0, and C is negative 25, because B, remember, always has an X behind it, and there's nothing with just a single X. That's why it's 0. So you could do the snowflake here, but I'm going to show you the method that, because we know this is difference of two squares. We've talked about these already this week, or Friday last week. So difference of two squares. I'm going to show you what we talked about. So we did this problem where we double distributed, and see how they matched, but one was minus and one was plus? And then what happened when we multiplied? That middle term canceled because they were exactly the same, except one had a plus and one had a minus, which made that positive and negative cancel each other, right? And that's how we ended up with a perfect square minus a perfect square. And then we did practice problems just like it. I don't have those filled out in that one. But so anytime that happens, what times what gives you 4x squared? That's the same. 2 what? 2x and 2x, right? What times what gives you 25? 5 and 5. However, it's negative, so one's going to be positive, one's going to be negative, right? Might help if you can see what I'm saying. Sorry. So it's literally, you just set up your two parentheses, and you have 2x plus 5 minus 5. That's it. Now, if you ever have that two terms and I'm telling you to factor, check for a GCF if they're not perfect squares and see if that created perfect squares. Sometimes that GCF makes it look like it's not. Okay, last two go pretty quick. On number 9, what do we have to do first? We have to take out the GCF. This is what happens if you don't take out the GCF. So I want to show you something. if you look at this front, you don't have to flip, but like first term times first term, what's 4x times x? What's 4x times x? 4x squared. It gave us the first term. So first term times first term gives me first term. What's 3 times 1? 3. Last term times last term gives me last term. That's a quick way to check your work. Now, is it 100% accurate every time? Not if you messed up somewhere in the middle, because we did not check the b value. But if that doesn't work, you know you're wrong. Does that make sense? If you don't take out your GCF, that won't work. Like, you'll factor this and you'll still have a 3x and a 3x. Well, is 3x times 3x 9x squared? 3x squared? No, it's 9x squared. So it won't work. You have to take your GCF out with this method. So what is my GCF here? 3. Now, another reason it's good to take out your GCF is you don't want to do this with big old numbers. Okay? It makes it harder. So we take out that 3, and we're left with x squared plus 3x minus 10. And I'm going to bring that 3 down here so I don't forget that it's part of my answer, and I'm going to ignore it. And I'm going to find my new a, b, and c. What's a? Perfect. What's b? C? Yes. So a times c. B is 3. B for bottom. If you struggle with remembering which one goes where, B for bottom. Okay, and then A is 1, so 1x, 1x. What multiplies to give me negative 10 and adds to give me 3? Or subtracts, huh? 5 and negative 2. Positive 5, negative 2. A is 1 now, so there's nothing to simplify. We have x plus 5 and x minus 2. Number 10, what do I do? Yeah, take out my GCF. What's my GCF? 4. So when I take that out, y'all, I'm left with x squared plus 6x plus 7. So now I try to factor that. Well, a times c is 7, b is 6, a is 1, so 1x, 1x. What multiplies to give me 7 but adds to give me 6? Well, what multiplies to give me 7 ever? 7 and 1. That's literally the only option for 7. Will 7 plus 1 ever equal 6? So we can't keep going. This is my final answer. Now, we call the middle of it prime. We can't call the whole thing prime because technically we factored this first one, right? We took the 4 out. Isn't that a factor? So technically we did factor it. We just can't factor it further like we did the other ones. So if it doesn't work, check your calculator, make sure, because sometimes y'all get a little eager to put prime and get really excited about it and think you're done, and they're not prime. So this is what you're working on. There is a practice. Now, there is a front and back of the practice.